The first kind of transformation we talk about is translation. Translation means moving the graph up, down, left, right, up, down, left, right without changing the orientation, the size, nor the shape. So it is only movement. Alright, consider it as just drag and drop. So suppose we have the original graph is like this, right? In red we have y is fx, so this is y being f of x. Now we can move the curve up and down. To move up, we might have move up by k units, for example. It's move up by k. K is greater than 0. Alright? Then the new graph will be y being f of x plus k. Alright? It's easiest to tell. You just add k to the original equation. So coming down, if it is moving down by k units, once again k is a positive number, then the orange graph is y being f of x minus k. Right, so add k to the graph means that to move it upwards by k units. Minus k from the graph means that to push the graph downwards by k units. Alright, so this is up and down. Now left and right is another story. When you move it to the right hand side, alright, like this. Say you move to the right hand side by h units. H is greater than 0. Alright. When you move to the right hand side by h units, there are two differences. Number one, it is subtraction instead of addition. Alright. Number two, the change is applied inside the bracket. It's f of x minus h. Alright. If it is moved to the right hand side by h units. Now, the difference between inside the bracket and outside the bracket, you have to refer to the previous video about function notation. Alright, it details on the difference between inside and outside the bracket. So finally, when you move the same graph to the left hand side, alright, when the graph is moved to the left hand side by h units, that would be y being f of x plus h. Alright, so this change once again is applied inside the bracket. So going up is plus k, going down is minus k, but outside the bracket. To the right is minus h. It's kind of reverse, right? If going to the positive y direction is add k. But interesting enough, to the positive x direction is minus h. So it's an opposite you have to bear in mind. And left and right, the changes they are applied inside the bracket. This is going to be a recurring theme. Alright, later on when we have other transformations, if the changes to the graph is being made up and down, the changes in the equation are outside the bracket. If the changes to the graph is being applied left and right, then the changes in the equation is inside the bracket. Alright, bear this in mind. So up and down is outside the bracket. Left and right is inside the bracket. Alright, bear this in mind. Now, let's take a look at one example that combines the two movements. Alright, so suppose we have the original red graph. It says x squared minus 2x. Alright, the vertex was at 1 and minus 1. Now you move it so that the vertex goes to minus 2 and 1. Now, in other words, you have to decipher that transformation. It is a translation. It going to the left hand side by the purple arrow, 3 units. And then it goes up by the green arrow, 2 units. So what is the equation of the new one, the blue one, right? Now the blue one will be a combination of the purple and the green transformation. The purple transformation is to replace, when you move to the left hand side by 3 units, is to replace all the x's with x plus 3. That is the meaning of f of x plus 3. Alright, you replace all the x's with x plus 3. So that is x plus 3 squared minus twice x plus 3. Alright, x squared minus 2x was the original equation. Now you replace all the x's with x plus 3. Alright, so the purple thing is moving to the left hand side by 3 units. And how about the green one? The green one is moving up by 2 units. So the green one is simple. You just add 2 to it. Alright. So if you expand the bracket and simplify the equation, x plus 3 squared, now using the method I shared with you last time, x squared, x and 1. So x plus 3 all squared will be 1, 6, and 9. Alright, minus 2x and 3 will be minus 2, minus 6. and then you add 2. So after all, you have x squared and 4x and 5. This is the final answer to the blue equation. The blue graph will be this one. Alright, and I just share with you how do I expand polynomials like this. Alright, so bear in mind there are 2 transformations involved. One is moving to the left hand side by 3 units, denoted in purple. One is going up by 2 units, denoted in green. Alright. Now let's look at another past paper question which is less numerical, no numbers. We have the original curve, y is f of x, right? So all the y is f of x is the one at the middle in all the 4 options. So we want to see what if I change the graph into y being f of x minus 2 plus 1, alright? So you need to figure out what are the corresponding changes. Y is f of x minus 2 plus 1. So there are 2 changes, right? Namely, one of them is called plus 2. Alright? The other is called plus 1. So how do you visualize these 2 changes? If you applied plus 2 inside the bracket, it's inside the bracket, right? So it's a left-right movement. Plus 2 means it is moving to the left-hand side by 2 units. Left-hand side by 2 units, if you refer to this diagram. Alright, f of x plus 2 means moving to the left-hand side by 2 units. And what does that plus 1 mean? This plus 1 means move upwards by 1 unit. So you are looking for the new answer. We'll be moving to the left-hand side by 2 units. I'm sorry, it's minus. Sorry, I copied the wrong equation. It should be minus 2. Alright. So minus 2 will be moving to the right-hand side by 2 units. Alright. So we are looking for the solution that we take the red graph, move it to the right-hand side by 2 units, and move up by 1 unit. So the answer goes to C. Alright. It's moving to the right-hand side by 2 units, and then go up by 1 unit. Alright. So that is the answer. But there are 4 other graphs as well, right? Maybe we look at what are the equations for the other 4 graphs. Alright, we can also take a look at the equation for the other 4 graphs. For example, answer A. Alright, how do you arrive at A? From the red graph, first of all, you move to the left-hand side by 2 units, and then you move down by 1 unit. Alright, move to the left-hand side is f of x plus 2. 2 units to the left-hand side. Alright, and then moving down is minus 1. Alright, so this is the corresponding equation for A. Alright, minus 1. This is the corresponding equation for A. So likewise, we can have that for B. That is f of x. What is this? This is minus 2. Alright, moving to the right-hand side by 2 units. And then you go down by 1 unit, so it's subtract 1. And finally, for D, that is a move to the left by 2 units, so that is x plus 2 inside. Alright, and then going up by 1 unit, so that is a plus 1. Alright. So you know, in addition to the correct answer for the A, B, and D for the other wrong answers, in fact, we have a corresponding equation derived from the red graph f being fx. So this is translation, one of the easiest but the most common transformation. Alright.